Welcome to the Crazy Hat Chemist. So another video in bonding and molecular structure. So let's get started. Bam! So today we're talking about the compression of bond angles. Okay, given the same number of domains, lone pairs of electrons on the central element compress bond angles of bonding domains. So we've got three examples here. Okay, the first one is tetrahedral, the second one is trigonal pyramidal, and then the third one is angular or bent. Okay, all of them have four domains, and that is the first one that's tetrahedral is AX4, trigonal pyramidal is AX3E, and then angular or bent is AX2E2. They are all sp3 hybridized. That means they have four domains, and you can see that right here. The tetrahedral is 4 bonding, 0 non-bonding. The trigonal pyramidal is 3 bonding and 1 non-bonding on the central element. The bent or angular is 2 bonding and 2 non-bonding on the central element. Okay, the key part about each one of these is that the tetrahedral structure has no lone pairs, the trigonal pyramidal structure has 1 lone pair, and the bent or angular structure has 2 lone pairs. And what happens is you have a compression of bond angles. So that is a compression of bond angles, a squeezing of the bond angle. So I'm going to show you a molecule example of each one. This is the tetrahedral example right here, and this bond angle here is 109.5. So this is our standard of which the other two are based on. Okay, so what we're going to do is we're going to take this here and rip this off here, this bonding domain, rip it off and put a lone pair of electrons on that central element. Okay, you're still going to have 4 domain structure of electron domains, but some of them will be bonding and some of them will be non-bonding. Okay, so here is that next slide structure. I've taken off the bonding pair of electrons and put in a lone pair of electrons right here. So what this has done is it has compressed the bond angles here. So instead of 109.5, as you would expect for a tetrahedral arrangement of electron domains, this is actually 107, or less than 109 certainly. Now what we're going to do is we're going to do one more here. So this is the trigonal pyramidal-like structure here. Okay, the next one is going to be the bent or angular. So we're going to rip off one of these bonding pair of domains right here, and then we're going to replace it with another lone pair of electrons on the central element, and that's going to be here like this. So I got 2 non-bonding and 2 bonding domains. These 2 non-bonding domains will compress this bond angle even further. Again, it has a tetrahedral arrangement of electron domains, but 2 of them are non-bonding, and these non-bonding electron domains compress this bond angle. You would expect with a tetrahedral arrangement of electron domains to have 109.5, but as we saw with the trigonal pyramidal structure with 1 lone pair of electron domains on the central element, it compressed the bond angle to approximately 107. This one is with 2 electron domains as lone pairs, then it will compress the bond angle even further, now down to 105. So one of the key features here is that this region, this gray region here, this is a localized set of electrons between the central element and the outside element. So these electrons between these 2 atoms, in this case an oxygen and in this case a hydrogen, this gray area, these electrons are localized between these 2 atoms. The lone pairs of electrons here, so this is 2 lone pairs and this is 2 lone pairs. These 2 lone pairs of electrons are delocalized, so they're spread out even further because they're trying to attach to something. Okay, that is, they are not between one element and another being localized in between 2 atoms. They are delocalized, if you will. And so that really helps to understand why there's a compression of the bond angle, because these are spread out, consuming a lot of space, and it compresses this bond angle. Okay, so hopefully that makes sense to you. That is another crazy hat video, and I got a crazy hat here. Wait, I got one cool thing with this hat that I can do here. I got to take off my glasses here. Give me a thumbs up if you like that video. Subscribe to my YouTube channel, and keep on with the chemistry and play some hoop.